Okay, so this is the first lecture, Psychology is a Way of Thinking. Um, just as one tip, um, if I am speaking too slow, you can always use the settings in YouTube to adjust the playback speed. And so you can speed me up. You can do like a 1.25 times or 1.5 times speed. If I talk too fast for you, you can always slow it down. So definitely encourage you to use the settings in YouTube to be able to speed me up or slow me down, whatever your preference is. So after hearing this lecture, you should be able to explain what it means to reason empirically. You should appreciate how psychological research methods can help you become a better producer as well as consumer of research, and then describe 5 practices that psychological scientists engage in. And for one of these in particular, one of these 5 practices, I'll be going into quite a bit of detail, as the textbook author does. And this lecture follows chapter 1 from the Morling textbook very closely. So I'm going to review why the producer role is important, why the consumer role is important, and then the benefits of being a good consumer with a couple examples. So the first reason, and so when we're talking about a producer of research, we're talking about somebody that is actually conducting the research themselves. And so this role is important, one, for coursework in psychology, particularly if you go on to advanced courses, especially lab classes will require you to do your own research. Certainly then in graduate school, if you decide that you want to go to graduate school, and especially if you pursue a doctorate, you'll need to do a research project, which is typically a thesis or a dissertation. And then being a producer is important for working in a research lab. For those of you that plan to transfer to a CSU or a UC, it's very common for undergraduates to join a research lab as an assistant. And this is a particularly good thing to do if you think that one day you might want to apply to graduate school. Most psych majors, as well as majors in other social sciences like sociology or anthropology or poli-sci or whatever, don't go on to eventually become researchers. Okay, most just don't. But it's still important to be a good consumer of research for taking psychology courses or other courses in your fields, whatever they are. So being able to read psychological research or social science research more generally, to be able to read a study that is published in a scholarly journal, you need to be able to read it and understand it, including the methods and the statistics. So it's important to be a consumer to just understand psychological research in the studies that are produced. You'll also often find news stories that are based on research. So if you think about the types of media that you typically consume, and particularly news sources, you might be looking for news that is related to psychology or other social science fields. Maybe it's even related to health in general or mental health, relationships, dating, politics, social justice, whatever you're interested in. You might go out and try to find some news on the topic, and many of these news stories are bound to include references to psychological or social science research. So being a savvy consumer of research will help you distinguish good research from bad research and help you understand whether you should take the news story that you read seriously. And then for your future career, understanding research is also likely to be important for a job that you might have in the future. So whether your goal is to be a social worker, a teacher, to work in sales, to work in human resources, you need to know how to interpret research with a critical eye. So I like to think that even though this class is about research and psychology, you're going to be learning some basic concepts and principles that will help you to understand and interpret many different types of research, and I would say kind of data in general. It's also true that for those of you that want to go on to become a clinical psychologist or a counselor, a social worker, a marriage and family therapist, you need to be able to know how to read research to be able to understand whether different therapies are effective. And so, in fact, obtaining a license in these professions to be a clinical psychologist or to be a marriage and family therapist, you have to know the research behind evidence-based treatments. So an evidence-based treatment is a therapy that is supported by research. So just as one example, there's scientific research showing that exercise can be an effective treatment for mild to moderate depression. So if you're a therapist that would say want to prescribe exercise as a way to help your patient deal with their depression, there would actually be some research to support that. Now, in contrast, there's little to no research support for many psychoanalytic techniques. These are the techniques that are associated with Freud. So things like free association, dream interpretation, there's virtually no research evidence behind those. So if you're somebody that wants to be a good therapist, you would want to understand which therapies are supported by research and which are not. And part of that is being able to understand the research. So that I kind of spoke to some of the benefits of being a good consumer, but I want to go through a couple other examples that the textbook author talks about. So one of the examples that the textbook author talks about is the Scared Straight example. So Scared Straight is a juvenile awareness program. And it involves organized visits of taking juvenile delinquents to an adult prison facility, and they basically get yelled at by some of the inmates. Okay, and so the most well-known of these programs is called Scared Straight. It was started back in the 70s. There was a documentary about it. So it was really, really influential. I've included a hyperlink here. There was a MTV program back in the late 90s about a Scared Straight program, and so it actually followed a group of juvenile delinquents into a prison, and they got yelled at by the inmates. So there's kind of, it's so if you want to get a better sense of what the programming looks like, there's an example there. And the specifics, of course, won't be on the exam, but just because this is an example in the textbook, I thought if you wanted to have a closer look at what these programs look like, that's a good kind of representative video of it. Right. So the program, a documentary about the program was originally made in 1979. And then after it aired, 30 states created laws mandating, making it mandatory to implement similar types of program where they take juvenile delinquents into prisons, they try to scare them straight as a way to deter engaging in criminal activity. And so, of course, a very important question is, well, do these programs work? Are they effective? So there were researchers that tried to answer that question. So again, the specific details here are not going to be on the exam, but just to kind of give an example here. So 2 major research studies were done on the effectiveness of these Scared Straight programs. So you see them listed here. So these are the review studies. It's conventional in psychology to name the study by the authors that conducted the study, as well as the year in which the study was done. So what we see here is the lead author of the study. Et al. Means that there was other authors. So Eos et al. Just meant that this is the lead researcher, and this person had other co-authors. The study was conducted in 2001. And then we see this other study that's done by Petrosino, and Buehler in 2004. Okay, so they covered, these reviews covered studies that were done across these dates. The 2004 study built on this first one. It just reviewed literature. So there was as many as 9 different studies that were done, several hundreds of participants. Um, Both studies ultimately concluded that recidivism rates, that is, going back and doing crime, were higher for participants of the Scared Straight programs compared to juvenile offenders that went through regular juvenile case processing, right? So they concluded that actually engaging in crime was more likely if juveniles participated in the Scared Straight program than if they didn't. Well, that seems fairly important considering that as many as 30 states mandated these Scared Straight programs. So research essentially showed that they were not effective and even had the opposite effect. And some um, journalists and scholars went on to suggest that every dollar spent on a Scared Straight program ended up costing government agencies more than $100 as a result of increased future crime costs. So having to incarcerate juveniles, having to have increased policing, court time, etc. So if there's a government or a government agency that spent $10,000 on a Scared Straight program, that would ultimately end up in a cost of $1 million because of the crime that resulted. So pretty dramatic. So we can see the benefit of doing the research and in really trying to answer the question, does this programming work? Here's just another quick example. Does mindfulness improve cognitive ability? So mindfulness is the process of openly attending with awareness to one's experience in the present moment. We try to pay attention and be aware of how we're feeling and have an attitude of openness and acceptance towards our thoughts and our feelings. So mindfulness interventions and particularly meditation have they've been practiced for thousands of years, particularly in Buddhist traditions, but these types of interventions have become very popular within the last 5-10 years, particularly in the United States, and I guess you could say kind of like the West in general. So the question is, if we engage in these mindfulness activities, does it improve our ability to think better, our cognitive ability? And there's quite a few research studies that would show that yes, indeed, mindfulness interventions do improve aspects of cognitive ability. So randomized control studies have shown that mindfulness interventions improve being able to pay attention, aspects of working memory performance, as well as problem solving performance, particularly working on like SAT problems and things like that. It's so this would of course lead to some excitement that, oh, I'm going to start meditating right now because that's going to help me think better. Well, maybe not. So even though there is research support for these mindfulness interventions, we have to be very we have to pay attention to exactly what these interventions involve. And so we might not want to just get an app on our smartphone and think that we're all of a sudden going to get a boost in IQ points or something like that. So you would have to follow the procedures fairly closely according to the actual studies, right? But that would at least be one takeaway, that there is at least some research that would be supportive of mindfulness and mindfulness techniques actually improving one's cognitive ability. So the takeaway from all this is that being able to gain skill in research methods will help you be a better consumer of information. You can decide whether certain programs are worthwhile or whether they're not worthwhile. So in the case of the Scared Straight programming, those would not be worthwhile. But if you wanted to explore mindfulness techniques as a way to potentially do better on the SAT or the graduate record examinations, there would be some basis for that. All right, so the next section is going to go over how scientists approach their work. So I'm going to hit these 5 points. So the first is that scientists are empiricists. So empiricism, it involves using evidence as a basis for making conclusions about the world. as you're going to see in the next chapter, there are a variety of ways of knowing about the world. So we can know about the world based on our intuition, our experience. We can trust authorities or authority figures. But psychological scientists base their beliefs about psychology on empirical research, on empiricism. Okay? So this is really using evidence from our senses or from instruments and measurements that help the senses. Empiricism is based on observation, but more specifically, empiricism is based on a scientific method where we use empirical reasoning that is a combination of logic and carefully organized, planned, systematic observation and measurement. So it's what we commonly know as the scientific method, and I'll review that in more detail next. So, kind of the second point here is that not only are scientists empiricists, but they test their theories using the scientific method, or what the author of the textbook calls the theory-data cycle. So the theory-data cycle involves asking questions that are based on theories, making predictions, and then collecting and reflecting on the data. That is, whether those data would be supportive or not supportive of the theory. So a theory is a set of statements that describe general principles about how variables relate to each other. A hypothesis is a specific prediction about the outcomes of your research based on the theory. And then data would just be a set of observations. So let's go over an example of this theory data cycle. And so this is an example that is also in the textbook. So the text gives an example of how psychologists have studied the concept of attachment. Attachment is a deep and enduring emotional bond that connects one person to another. So originally, psychologists proposed two main theories that they believed were important in babies forming attachments. So the learning theory of attachment was based on principles of behaviorism. You might remember the term behaviorism from your Psych 101 class. It had to do with like B.F. Skinner. It basically suggested that attachment is a set of learned behaviors. The basis for learning attachment is getting food. So a baby will initially form an attachment to whoever feeds it. And so they learn to associate the feeder, who's usually the mother, with the comfort of being fed through a process of classical conditioning. I said B.F. Skinner. Pavlov would be more consistent with that. And so through classical conditioning, they come to find contact with the mother comforting, but that's only because they've been conditioned with the food. So this was known as the cupboard theory. It's kind of like you take food out of the cupboard, so that infants learn attachment to the mother because they get food. So an alternative to the cupboard theory was proposed by psychologist Harry Harlow. He and others proposed an evolutionary theory of attachment, which suggested that children come into the world biologically pre-programmed to form attachments with others, because doing so would help them survive. So Harlow's explanation was that attachment develops as a result of the mother providing tactile comfort. He suggested that infants have an innate biological need to touch and cling to something for emotional comfort. So this was known as the contact comfort theory. So Harlow wanted to test his theory. Okay, so again, he started with a theory which is a general idea. And the general idea was that infants have an innate need to touch and cling to something for emotional comfort. And it's this contact comfort and not food that is the basis for a baby's attachment to its mother. All right, so that's his theory. It's a general set of principles. This led to the question, would infants choose comfort over food? So what he did then was create a research design. So he kind of very cleverly created two different surrogate mothers. And you might remember this from Psych 101 too. I know I go over it in my 101 class if you had me. But if you didn't, this is one of the kind of classic studies in psychology. So he made these two surrogate mothers. One was made of bare wire mesh, and it had a bottle of milk built in. This wire mother offered food, but not comfort. The other mother was covered with a fuzzy terry cloth and was warmed by a light bulb that was suspended inside. She didn't have any milk, or this terry cloth mother didn't have any milk. So this mother offered comfort, but not food. So this led to the hypothesis. Okay, a hypothesis is a prediction about the outcomes of the research based on the theory that is specific to the research design. So his specific hypothesis is that infants will spend more time with the cloth mother than the wire mother. If contact comfort is correct, they should spend more time with the cloth mother than the wire mother. So then he collected data. So he ended up having 8 monkeys who were separated from their mothers immediately after birth. He placed them in cages with access to the 2 surrogate mothers, one made of wire, one made of covered in the terry cloth. His data ultimately showed that the monkeys would cling to the cloth mother for 12 to 8 hours a day. When they were hungry, they would climb down, they'd go nurse with the wire mother, but then they'd go right back to the warm, cozy cloth mother. So these data were consistent that the attachment was made based on tactile comfort or contact comfort, and these data were inconsistent with the cupboard theory, which is that an infant will form attachment to a mother if it that provides food. All right. So just to review some key terms. A theory is a set of statements that are as simple as possible that describe general principles about how variables relate to one another. So, for example, Harlow's theory was that contact comfort, not food, was the primary basis for a baby's attachment to its mother. A hypothesis is a specific prediction that is stated in terms of the study design. So specifically, babies will spend more time on the cloth mother than the wire mother. Notice that this specific prediction is kind of only understandable once you know the research design. So that's what differentiates it from a theory, is that hypothesis is specific and theory is general. And then, of course, data are just a set of observations that can either support or fail to support a theory. This idea of either supporting or failing to support a theory is important. And it's important to know that research studies don't prove theories. The word prove should not be used in science. Researchers should never say that they've proved their theories. Why not? Well, as empiricists, scientists need to avoid making conclusions that they can't support with direct observation. Consider this set of observations that is also in the book. This raven is black. That raven is black. Every raven I have seen is black. Both of them, right? Therefore, all ravens are black. What's the problem with this conclusion? The problem, of course, is that we haven't observed all possible ravens. So it's possible, however unlikely, but possible, that a non-black raven exists. There could be an albino raven out there. So the possible existence of just one unobserved non-black raven prevents us from saying that we've proved, capital letters proved, that all ravens are black. All right? So we only support our theories. The data that we have are supportive of the theory, but because we can't possibly have every single observation out there in the world, we refrain from saying that we prove, that we have proven right? So it's a difference between science and a field like the law, right? In legal terms, the word prove is used all the time, and they use evidence. But it's a different approach to understanding the world. And scientists, as empiricists, are a lot more, you could say, tentative in the conclusions that they're willing to make. So you'll see it time and time again, particularly in popular press accounts of scientific research. You'll often see headlines about science proving one thing or the other. And I will say it is kind of a pet peeve of mine that this happens, and it's a pet peeve of mine that when students use the word prove. So take it out of your vocabulary, at least when you're talking about data supporting theories, right? We support theories, we don't prove them. All right, another property of good theories is that they're falsifiable. So falsifiability is the idea that a theory should lead to a hypothesis that, when tested, could potentially fail to support the theory. So Harlow's theory was a good example of a falsifiable theory because the monkeys could have spent more time with the wire mother that gave the food, right? He could have been wrong. And so if he would have gotten that pattern of results, his theory would not have been supported, right? So it could have been falsified. He could have been wrong. A bad theory is one in which it's impossible to ever show that it's wrong. So a conspiracy theory is an example of a bad theory. You can't ever prove a conspiracy theory wrong. I use the word prove. You can't ever show that a conspiracy theory is wrong. So, for instance, if somebody believes that the government is spying on them or that the government spies on Americans, but there's no evidence for it, they can't come up with a single piece of evidence, that person might say, well, of course there's no evidence. The government isn't going to leave evidence lying around that it's spying on you, duh, right? So that's an example of a theory that just simply isn't falsifiable. It's not a good theory. Here's another one that you might have heard of before. So in Psychology 101, you might have learned about Sigmund Freud's psychoanalytic theory of personality. You might recall that according to this theory, personality is composed of three different elements: the id, the ego, and the superego. The id follows the pleasure principle. This is our subconscious desires, our kind of deep, dark desires for sex and aggression and all this kind of stuff. The ego is the reality principle, and then the superego are our internalized moral standards. So according to Freud, basically the id and the ego are always fighting. They're in conflict between what we really want to do and our internalized morals, and this structure of the mind called the ego kind of reconciles between the two. According to Freud, he's one of the most famous therapists, or at least he was. Personality as well as psychological dysfunction, but particularly anxiety, are a result of the interplay of these three structures of the mind. So why is it that people have anxiety? It's because they haven't successfully resolved conflict between the id and the superego. Well, what if people don't show any anxiety? They're anxiety free. Aha, it's because the ego has reconciled the conflict between the id and the superego. So we see the problem with the theory is not being falsifiable because this is a theory that explains everything after the fact. Why do you have anxiety? Because there's conflict. Why do you not have anxiety? Because the conflict has been resolved. There's these imaginary structures, and whatever the case, right, whatever you observe, there's a way to explain it after the fact. So you can't possibly prove it wrong. It's non-falsifiable, and therefore not a good theory. Okay, so one other practice of psychological scientists is that they work in a community, and this basically means that they follow a set of norms. Norms are shared expectations about how they should act, and so there's 4 norms that the textbook mentions or presents: universalism, communality, disinterestedness, and organized skepticism. So I'll just kind of leave these here for you to review in the textbook rather than reading through them. But the kind of take-home message is that there are norms. There's norms for doing science, and you're supposed to follow them. As we'll learn later in the course, not everybody does. And so there's an ethics involved, and there are instances in which some psychological researchers don't play by the rules. And there's kind of dishonest research behavior. Another practice is that scientists tackle both applied and basic problems. So an empirical approach can be used to answer both basic and applied research questions. So applied research is conducted in order to solve practical problems. The word applied means that the findings will be directly applied to finding a solution to a real-world problem. So for example, a researcher might conduct a study to determine the best method for teaching children how to read. Basic research, on the other hand, has the goal to enhance the general body of knowledge about a particular topic. So an example might be to investigate what a 9-month-old infant can remember about hidden objects. This is the idea of Piaget's idea of object permanence. Okay, so it's trying to understand a more basic principle about how the brain develops. Not necessarily to solve any particular applied problem, but to just understand a basic developmental process. Translational research is often thought of as a bridge from basic to applied research, in which findings from basic research are then used to develop different applications. And there's a couple examples given here as well. This was a point actually that the textbook author made in a previous edition of the book. This is not in the 4th edition, but I wanted to bring it back because I think that it's a good point to make. And it's kind of this idea is that scientists dig deeper. So they rarely conduct only a single study. And it goes back to the idea is that a single study with a single piece of evidence, you can't prove anything. And that goes for a study. Any single study can be supportive of a theory, but it takes an accumulation of several studies to really result in strong confidence that a theory is true or not. So once a basic effect is found, what they then do is test explanations and boundary conditions. Why do I think this effect occurs? For whom does it occur? When does it happen the most or the least? So it's trying to find support for a particular theory and then also trying to test explanations and boundary conditions. Another part of the scientific process is to make the work public. Kind of doesn't do that good if the findings aren't publicized or published for the general public to use. So scientists share, and for other scientists to use. So scientists share the results of their research with the scientific community by submitting to peer-reviewed journals and participating in academic conferences. Peer-reviewed journals are those in which a scientist submits their research study, a written-up research study, to a journal. The journal editor then selects other scientists in the field to read the study, comment on the study, determine if the study has scientific merit, and then, based on the feedback from those other scientists, those peers in the field, the editor of the journal will make a decision as to whether that write-up of the study, the article, should be published or not. So the peer review process is very important because other experts in the field decide if the piece of work has scientific merit. Okay, and so that's kind of the scientific community, but what we hope is that research that is published in scientific journals, in peer-reviewed journals, ultimately makes it out into the world. And so journalism is an important process by which that takes place. So most of us ultimately read what is called the popular media or the popular press. It's magazines, newspapers, that we read online. It's what we hear on the radio. It's what we see on TV. And so these are sources that are ultimately written by journalists. And so the articles are easier to understand. They don't require the specialized knowledge in the field that you need if you actually want to go and you want to read the original article. So journalists play a very important role. Now, the journalists themselves usually find out about the research by they themselves read it in the scholarly journal or attend a conference, or they might even interview the researcher that conducted the research. Okay, so they make the science much more accessible to a wider audience. But there are problems. So journalists often get it wrong. And this is either by summarizing the main findings in a way that is too general and not specific or nuanced enough. And sometimes it's just plain getting it wrong, omitting key details or having an improper conclusion. So I've included this link and I've also posted it on Canvas. This is a clip from John Oliver's Last Week Tonight. It's somewhat lengthy. It's about 19 minutes, but I think it's really worth watching. I think it's hilarious, but there's some very great illustrations that he goes over of kind of journalists and people in the news getting conclusions from scientific research completely wrong. I will just kind of issue a warning that there's some language that might be offensive to some people. If you've watched John Oliver, you know that he says some kind of, outlandish things. So there is that. But absolutely worth watching. So, all right. Well, I hope you enjoyed listening to this lecture and then you know just a little bit more about psychological research and what psychological scientists do. Thank you.